Hey class, it's Bill Berry here with our second week's material in our Java 2 class. We are still in a semi-review mode. We're adding a few new topics each time, but in this particular week we're going to talk about jagged arrays because that's something that you may not have touched in your CSC 142 class, but you will need them for the upcoming project, so we are going to talk about those. Also, in the early part of the week, we're going to talk about inheritance and polymorphism. For those, I may just link in videos from the 142 class, so you'll see that the slide format changes, which will remind you that that's from the other series. So if you want to review those, again, you're going to be using those, so if you need a quick review, those videos will also be here. So let's start in and talk a little bit about jagged arrays and how they're different from what we've seen before with our standard two-dimensional arrays. Let's go down to this slide. There we go. Okay, so we're going to talk a little bit about what they are and how they're supported in different programming languages because they're not always supported exactly this way. And also, of course, because everything's going to be diagrammed, how are they diagrammed differently? Well, turns out not too differently. And we're going to look at the code, of course, and see how they're different than declaring a standard two-dimensional array. And of course, they can be multi-dimensional. That doesn't have to be just two. So let us also talk about looping, right? So how do you loop through these and is that any different? So several little quick topics, shouldn't be a long video. First, we know that all of Java's multidimensional arrays are arrays of arrays, right? They are always one array pointing to another array, and you can have multiple dimensions of it, of course. So the thing that's different here, the concept of a jagged array, is that not everything has to be the same length. Not all of the subarrays have to be the same length. And you've seen when you've looked at some of the object diagrams that we've drawn, because the fact that they're always arrays of arrays, you can kind of get the idea in your head that, hey, it doesn't really have to be the same length. The declaration sort of makes it happen in a 2D, standard rectangular 2D array, but it doesn't have to be, and you can get that idea just from the object diagram. So what you can do in Java that's cool is that you can declare the first level dimension. So you can say how big the first array is, right? Because in the end, every array has to have a size. It's an array after all. But you can declare that first level dimension, but then you can postpone the actual binding to the second level dimensions, right? So you can say, hey, I'm giving you the first one, and then later I'm going to create those other arrays and actually do the binding, which refers from that first array to the subarrays, right? And that means that as you declare, as you create those second arrays and bind them, each one can have a different size. There's no reason that you have to make them all the same. So you can use these in a lot of different languages. Some of the languages are listed here, right? A lot of the sort of modern object-oriented programming languages will have support for these. And even though by default it will create the same size arrays, they don't have to stay that way. And again, you can sort of do this other thing. So now in some languages, though, they do have what you might call true multidimensional arrays, and that's that they must be the same sizes. So when you declare standard type of arrays in languages like C and C++, you do get the same size for every single subarray. They're not necessarily done in memory differently. It's right. It's not like there's a contiguous block of memory for the whole thing necessarily, although there might be. I should look at the implementation before I say that. But you can do something like a jagged array because, of course, C and C++ have a very, very developed pointer system. So, of course, you can develop something to act like them, but the syntax is not going to be as straightforward as a standard simple two-dimensional array. So let's look at our weather example that we've used in a couple of cases, and let's see how it looks different. Notice that the overall diagram isn't any different. It's still main has a weather data array, and that's a two-dimensional array, of course. But when we declare it, we're just going to say, hey, this is what we need in the first dimension, right? The first array is just going to be 12. But the other ones are going to be different, right? So I'm not going to declare those at first. I'm going to postpone the binding to those things. So then I can create an array for January that just has the 30 days, right? Or 30, up to 30, right? 0 to 30 makes 31 days. February, depending on the year, might have 29, so 0 to 28, etc. So now I can create subarrays that are whatever length I want. And then when I assign them, I do the binding, right, that points from here to there. And that's fine, right? It's not all that exciting. You just have to do these separately, and you have to do them individually because they're all different lengths, so you've got to take that extra step. And then, of course, those point to weather days as usual, right? The rest of the story is exactly the same as before. So let's take a little peek at the code that we used before. Now this is for a rectangular or regular array, right? 2D array. So notice when we did this before, we declared 12 and 31, right? So we said, hey, every month has 31 days. Well, we know that every month doesn't have 31 days, so maybe we go through in this ... code and we set all the ones, well, actually we know they're already done by Java. We can set up any days with weather, and all of the days that don't have weather, right, where there is no weather day pointed to, they're just going to be null. So things like February 29th on years that don't have it, and 30th and 31st, they're going to have nulls, right? So when we loop through this array, we have to be careful. Notice when we did our standard rectangular array, we started with month at 0 and went to the length of that. Now remember, when you're using this, let's go back a slide, you're talking about the length of this, right? This is 12, all right? We have 12 months. So when we're looking at the length of the whole thing, right, this thing, its length is 12. So that's our first dimension, and then in the nested loop we went from 0 to whatever this was. Now in this case, because it was rectangular, we just use 0 because it really doesn't matter which one. They're all the same length, right? So we just said, hey, if we pick the 0th one, again, let me go back a slide, right? Whichever one that is. Now this is the jagged example, so in the other example they were all 0 to 30, right? It was all 31. So we just picked the first one and said, hey, that's good enough. So our loop always looked like that, but then we also have to think about the fact that, hey, maybe we have to deal with these nulls, right? We have to deal with the fact that sometimes the array has more stuff in it than we want, and so we have to think about what to do with those extras that are left over. So in this case, we have an if statement that's going to filter those out. So that's how the rectangular array works. Now let's look at the example doing the same thing with a jagged array, right? And of course I've already said this, so I'm just putting these up on the slide so you can see them. Now let's look at the jagged array and see how that works. Notice that when we declare a jagged array, it's not that there's not a keyword, right? You don't actually say the word jagged. What you do is you can just leave out this second dimension. The first one you have to do, right? Because it's creating that first array, so it has to have a dimension there. But then the second one, you just leave it empty. And then you must fill in those at a later point before you want to use them. So in this case, I can say, hey, I'm going to point the 0th element in that array, that first array, to a newly created array of weather data objects that have a dimension of 31. So January has 31 days, therefore I'll create an array that's 31 days, and I will bind it, I will point to it from the 0th element in my master array. February has 29th if it is leap year, etc. So now we have a whole bunch of lines here that have to create all of the individual ones because each one's a different length, so they have to be created individually. You could have a loop that did all of the 31-day months and then all of the 30-day months, etc., and then handle February separately. So I'm not saying you can't loop, but somehow you have to go and create all of those individual arrays. Now, when you go to display it, if you're using a standard for loop, right, what does that look like? Well, it works the same, except that now we better make sure we're looking at the specific month that we're talking about, right, because they all have different lengths. So here, rather than using 0, which we were sort of casually using with a rectangular array because we know that they're going to be the same length, instead we simply use this thing, right, which is the month that we're talking about, and make sure that we're looking at the length of that sub-array, right? So where this is talking about the length of the top level, the first dimension, now we have to drill in and dig into the month, the specific month, and look at the length of that, right? So if we were looking on our object diagram, that would be the second level array, all right? So that's the difference if you're using a standard for loop, right? But one question is, can we write a for each loop, right? What does a for each look like when it comes to a jagged array? So let's take a peek at that. Well, I love me some for each loops, so look how easy it is here. Remember, this is the collection name, right? So the collection itself is this whole thing, right? Weather Day 2016. So I loop through that. Each one of the elements in that is an array of months, or weather days, sorry. It's an array of weather days, right? And I'm going to call the variable month because that's going to loop through each month. But then in this second level, I take this thing and I make it the collection that I'm looking at. And within that, each one of those elements is actually a weather data item, right, element, which is all I'm going to call day. So now the loop just has to deal with day, and that's each day pointed to one at a time in this for each loop. Notice here I don't even have to worry about the jagged nature because this automatically comes down, right? When I use this variable here, that's automatically taking into consideration that each month is going to be pointing at a different array. Therefore, day is going to be the correct thing for that. So a for each loop works really nicely, and you don't have to worry about the fact that it's jagged. It's just going to work. And notice here, we don't have any nulls to deal with because every single array is already the right size. So we don't have to deal with anything about nulls, neither up here nor down here. It's just not going to be a big deal. So that's pretty darn good, right? So in this case, yes, we like that a lot, right? We like rectangular arrays. And we like jagged arrays for this purpose too. So that is just a quick introduction to jagged arrays. Really, the topic is not that hard. All you have to know is you postpone the creation of whatever other levels you want. If you have multiple dimensions, more than two, of course you can do the same thing there, but you postpone that and then later create those and point the initial array to whatever subarrays you've created. So that's all you have to know. Jagged arrays are pretty darn easy. Again, you'll need them in your second project. So we'll wrap up this video. Remember that the next couple are going to look a little bit different. The slide theme is going to change because it's going to be in 142 mode. And so you'll see some reviews, if you'd like, on things like inheritance and polymorphism and things like that. So we'll see you back in those videos. Thanks for watching this one.